So, hi everyone. So, welcome to this AI Agent Roadmap series. If you ever wonders how ChatGPT works, what are LLMs, what are tokens, embeddings, and transformers, and how do AI agents make decisions, so they are in the right place. In this series, we will go from the complete beginners to building production-ready AI agents. So, today is phase one, AI fundamentals, like AI roadmaps and fundamentals. Okay, so this is the phase one. In this series, we will go complete beginners, okay, to building production ready AI agents. So, like in this series, this is the foundation for everything else. If you understand this phase well, topics like RAG, tool calling, memory, MCP, and multi agent system will make much more sense. Let's get started. Okay, so there is one first topic. It's what is artificial intelligence. So artificial intelligence, or AI, is the ability of machines to perform tasks that uh, normally requires human intelligence. Like, so they use human intelligence for doing some or perform some task. Okay, so these tasks include understanding of language recognition, image, making decisions, solving problems, learning from the data. So this is what AI. So now, for example, like ChatGPT, like think about ChatGPT. When you ask it question, okay, so it understand your language. So first is the understanding of language. Okay, then generate an answer. So that's ability is considered as artificial intelligence. Means they can understand your language recognition, and according to that they can generate the response. And so that's what we called, that is considered a artificial intelligence. But here is important. Okay, so AI does not actually think like humans. Okay, so they are not like things like humans. It does not have emotion or consciousness. Okay, instead of it, it recognize pattern. What it's recognize or learning from the data or patterns. So amount of data and predict the most like response. They can predict through the trained data. Okay, so AI is essentially very advanced pattern recognition. So this is first topic, what is AI, artificial intelligence. Okay, now we come to the, now let's move one step deeper. What is machine learning? Okay, so machine learning is the subset of AI. You all know the AI, the machine learning is the subset of AI, where computers learn pattern from the data instead of being explicitly programs. Okay, so like imagine you want to detect spam emails. So right, so the traditional way would be write rules, like, okay, rules. So this is the traditional way. You write some rules regarding to detect the spam emails. Okay, if the email contain congratulations, you want 1 million, so mark it is spam. This is the example of how you can create the rules to detect the spam emails. Okay, so but there are millions of ways spam emails can be written. Okay, so instant with machine learning, we provide the computer with millions of example of spam and non-spam emails. So this is what we can say the machine learning means. We will provide the we will provide the millions of records related to the spam or non-spam related emails. Okay, so the models can be trained regarding that. Okay, so the computer study this example, and they can discover the patterns on its own and builds models. So they can learn from the data we provide, and they can create one models, or we can say they can train their models. This is why machine learning is called the learning from the data, and they can predict and they can detect the spam data. Okay, so this is the example of what machine learning. Now now imagine that machine learning itself is not powerful enough for complicated tasks. Okay, so like recognition, face, or understanding the language, because that is the machine learning. And so now that's where the deep learning come into existence. Okay, so what is deep learning? So deep learning is a branch of ML, machine learning, that use neural networks with many layers, hence deep. Okay, so based off for image, speech, language, it is each layers learn more complex features. Okay, so I will explain you. Deep learning use neural networks with many layers. Okay, so the word deep simply means there are many hidden layer inside the networks. So imagines recognition a cat in an image. First layer detect edges. Okay, first layer, this is the image. First layer detect edges. Second layer detects simple shapes. Okay, what is the shape of the cat? Okay, the third layer detects ears and eyes. This is the third layer. And the fourth layer combine those feature into a complete cat. So the what deep learning, they can combine this whole feature and to create the face of the cat. Okay, each layer learns something more complicated than the previous one. So that's why we called as deep learning. Perform was well in computer vision and speech recognition and language models like ChatGPT. So this is what we can call as deep learning. You understand why we use deep learning and what is this. Okay. So now the fourth topic is came into picture. It's called now let's understand the brain of deep learning. Now this is the stepwise procedure. Okay. First you learn the AI, what is AI, and the second you learn the ML, machine learning. The third we learn deep learning, what is deep learning, and inside this deep learning there is a called neural network. So this is the brain of deep learning. Okay, a neural network is inspired from the human beings. So this is inspired from the human beings because in the human brain also there is a neurals. Okay, we called as the neural networks. That's why a neural network is inspired by the human brain. Okay, consists of neurons, nodes connected together. So like in our brain contain billions of neuron connected together. Okay, this is the same way the neural networks in deep learning is consist. Okay, similarity is like artificial networks. Similarity artificial network contain artificial neurons connected by mathematical weight. Okay, so that's we called as the neural network and same as the human brain, because in artificial neural networks also contain the artificial neurons connected by mathematical weights. Okay, and simple neural network has three part. There is the input layer. Okay, and input layer, so this is the what receive information. The hidden layer, this is the hidden layer. And the third is the output layer, means they can like produce the final prediction. So there is the first input, so this layer we can like this receive information. The hidden layer, they can process the information, and third they can produce the final prediction. Okay, so this is what the neural networks. So example predicts house price, area, bedrooms, location, age, output 95 likes. Okay, so this is the input. Okay, input, area, bedroom, location, age. So this is the output 95 likes. Means in the hidden layer they can process the information whatever you provide. Okay, so now we came into the picture is transformation architecture. Okay, now we arrive at one of the biggest breakthrough in AI history, transformers. Okay, so each modern large language model is based on the transformation architecture. Okay, so introduced in 2017 in the paper of attention is all you need. Big shift from old models. Okay, process all words in parallel using self attention. They can process the all words in parallel. Faster handles long range. All models like LLMs, ChatGPT, Cloud, Gemini, LLM, etc. are based on transformers. Okay, so every models like large language model is based on the transformer architecture. Okay, ChatGPT, Cloud, Gemini, Llama, Quen, all of them are used transformer. Before transformer model process word one by one. Okay, so previous like before transformer, like the model process bird one by one. Image reading is this sentence. Okay, I love learning before the transformer. Okay, and after the transformer, before transformer I love learning AI, so one by one they can process, but after transformer I love learning, they can process all in similar, all in parallel, sorry. So this is how the transformer architecture came into picture. This was slow and made it difficult to understand long range relationship. Transformer change everything. Okay, is instead of reading one word at a time, so they process all words together. Every word can communicate with each other word using something called self attention. So this is something called self attention. So this dramatically improve speed, understanding, and long context reasoning. So that's why transformer become the foundation of modern AI. So this is very important. Okay, so now what is the we have the important is sixth, attention mechanism. Okay, now let's understand the magic behind transformers. We understand in transformer what is transformer and what is the effect in before transformer and after the transformers. Now we understand what is the attention mechanism. Okay, so attention tell the models which what's important. Attention, you need to understand what is attention. Attention means focus. Okay, so attention helps the model focus on important words while understanding its tensions. So it tells the model which words matter most. So this is what the attention mechanism. Okay, take this sentence: the dog chased the cat because it was scared. So who is scared? So like the dog or the cat. So the human understand that it's referred to the cat. The model use attention to make the same connection. Here is another example. Apple released a new iPhone, Apple stock increase. Okay, so Apple stock increase. The model understand the Apple refers to the company, not the fruits. Okay, without attention, model language understand would not be possible. So this is the real example, and what is the attention mechanism is important in the artificial intelligence. Okay, now we here is something many beginners don't know. So what is token? Okay, large language models do not actually read words. So this is the words. Apple releases new iPhone, Apple stock increase. This is the word. But LLMs, large language models, do not read the words. They read tokens. And what is token? Token is the smaller part of the words. Okay. So they read tokens. A token might be a whole word, part of word, a number, okay, or even a punctuation. For example, artificial intelligence might become multiple token depending on the tokenization. So this is the artificial intelligence. So this is the depending on the tokenization that we used in the LLMs. Okay, like context size, also API pricing, input, what is the input length, output length, every depends on the token. Whatever the response generated by LLMs, so they are generally based on the context size. What is the context size? What is the API pricing? What is the input length and output length? So it depends on what everything is measured in tokens. So this is what the tokens. Now talks about the embeddings. What is embedding? Okay, so computer does not understand words. We all know, like computer is a machine language, and like it's always understanding the 0 and 1. So this like computer don't understand words, they understand numbers. So every word, like sentence or paragraph, is converted a list of numbers called as embeddings. Okay, so embeddings, we are converted all the text and images into vector, the list of numbers that captures meaning. So this is what we can call as the embeddings. So so think of like assigning every piece of text a location is a giant mathematical space. Okay, similar meaning close vector used in search recommendation track. So Netflix also use this embeddings, and the movie recommendation also use this embeddings. Drag also we are using in this. So example king, so 0.1, 0.4, 0.83, this is the embeddings of king. Queen, this is the embeddings of queen. Pizza, this is the embeddings of pizza. Rocket engine, this is the embeddings of. We are storing the all that related data to embeddings. Okay, this time. Now next is the context window. So think of context window as the model temporary working memory. Okay, everything inside the context window is visible to the model while generating a response. So if the conversation becomes too long, okay, and exceed the context limit, older information may be dropped. Okay, so that is why some model forget details from earlier is very long conversation. Larger context window allow models to analyze long documents, books, research, and papers. Also, like large code base more effectively. Means this is the context window. and we are providing some information they can store. But if the information is more than this, so they can drop the previous data. Okay, they will drop the previous data. That's why this is the called context window, or what we can say the memory of the agents. Now is the temperature. 10 is the temperature. So temperature controls randomness. Okay, temperature control randomness output. Low temperature, more focused, deterministic, good for good code, math, and factual answer. Okay, so this is the ideal for coding, mathematical APIs, and the structural response. A high temperatures make more creative and diverse. So this is useful for storytelling, brainstorming, poetry, and making marketing ideas. Think of temperature as the model creativity dial. Okay, this is what we can call as the temperature in AI agents. So what is top P sampling? So top P sampling, which possible next word the model is allowed to consider. Imagine the model predict the next word with these possibilities. Kate 40%. Okay, Kate 40%, dog 30%, bird 50%, rocket 5%. If the top is set, okay, if top is set 0.85, the model only consider the highest probability words until their cumulative probability reaches 85. Okay, so this help avoid very unlikely or non-sensational choice while allowing some variety. Okay, so instead of considering all possible next tokens, it chose from the top P tokens where cumulative probability greater than P. Okay, so this is why the top P, or we call as the nucleus sampling. This is helpful for predict the next word. Now we came into the finally, let's discussion as the hallucination. What is hallucination? So hallucination occurs when the model confidently generate information that is false. Hallucination means they can provide you the wrong information. For example, if you ask about the historical event and that is never happens, the model might still invent an answer. So this is what we can call as the hallucination. What does happen? Because the model predict like text rather than verifying facts, hallucination become more common. Okay, the prompt is ambiguous. The model lack relevant knowledge. So the answer requires the real-time information to reduce hallucination. So what we can, how to reduce? Use the retrieval augmented generation RAG. Okay, provide clear instruction. Please give the clear instruction to whatever the model you use. Ask for citation when appropriate. Ask for source or citation, like ask for fact. Okay, verify important outputs with real data. Okay, so this is what the first roadmap. Now the final summary is, let's take everything into the review. AI is the brain. Okay, broad field of intelligent machines. So machine learning teach computer from data. Okay, so machine learn AI, what we can say AI. Okay, now deep learning use large neural networks. Okay, on what is neural networks learn patterns, and transformer process the language efficiently. Attention help models focus on important relationships. Token are the units. Okay, and embedding convert meanings to numbers. Context window determine how much information the model can remembering during the request. Temperature controls creativity. Top n controls which candidate words to be selected. Okay, and hallucination are the confident but incorrect information. So together this concept from the foundation of every modern AI. Okay, system. In this next video, we will move to phase 2, the large language model, where we will explore GPT, Claude, Gemini, Llama, APIs, functions, calling, streaming, and how LLM actually work or generate responses. Thanks for watching. I will see you in the next episode.